So in section 8.2, we're actually going to put to work all that stuff we did in section 8.1 about formulating a hypothesis, finding a p-value, and then making a decision based on that p-value to reject or fail to reject. Now, the process that we're going to follow is going to pretty much go along with the same 6 steps that I've outlined here in this handout. Now, in order to test a claim involving a population proportion, there's a few assumptions that you have to be able to make. So the first one is that you've got observations from a simple random sample. Now, we're not going to be able to actually test this or see this. It's just an assumption we're going to have to make. We will make it. Second is that the conditions for a binomial distribution are satisfied. So does anyone remember what those conditions are? Conditions for a binomial random variable? What was the word that we used to help us decide if something satisfied a binomial random variable?
Normal?
No, it was an acronym.
Was it fits?
Fits, yes, well done. Fixed number of trials, independent samples, 2 outcomes, same probability of success for each trial. And the last thing is that we're going to need to assume that this number, NP, the number of successes, and NQ, the number of failures, are both greater than 5. If that's the case, then we can approximate the probabilities involved and make a nice, or perform a nice hypothesis test. So here's our 6 steps. And I've modified this to reflect the fact that we're using technology for this. The first step is we're going to state the null and alternative hypothesis. Okay, that we kind of expected. So that's our first step. Decide on alpha. Now, typically that's actually going to be given to you. If it's not, then choose 0.05 or 0.01. Now, for the rest of these, a lot of times I'll give you an or, one or the other. For us in this class, it's always going to be the first one. Input your data or summary statistics. Now, where are you going to input it? In your graphing calculator or in Statistic or some other program that you're going to use to analyze your data. So that's our third step. Our fourth step is going to be find the p-value or calculate a test statistic. That's the hard way. That's old school. Hopefully, again, we're going to be doing the first one here. The fifth one, and I should have changed this up a little bit. If the p-value is less than alpha, which we decided in step 2, then reject H naught. So that's the part that you're going to focus on here. And then last but not least, state your conclusion in words. And I've got a handout for that. So that would look like this. So for that, you're going to decide, does your original claim contain the condition of equality? And then follow this flowchart down until you decide how you're going to word your claim. This is more important than it has been in years past because software has made it a lot easier to get to this point. So I'm going to put more emphasis on you being able to communicate your results in plain English, which is what this is, wording the final conclusion. Let's go all the way up here to the top, example A, and start with that one. So I think I'm going to perform this as a hypothesis test as opposed to going through all the things that are here. We'll take a look back and do some of these things as well. So a certain drug is used to treat asthma. In a clinical trial of the drug, 15 of 253 tested subjects experienced headache based on data from the manufacturer. If the company calculator display shows results from the test of the claim that less than 9% of treated subjects experience headaches, use the normal distribution as approximation of the binomial distribution, and assume that a 0.01 significance level to complete parts A through E. Wow, there's a lot going on there. But let's start out with what I have in yellow and what we're going to be doing in this section, which is our step 1. Step 1 just says, all right, state the null and alternative hypothesis. So let's go back up here. Step 1, state the null and alternative hypothesis. Okay. Each O, each A. And that's back up here. Less than 9% of treated subjects experience headaches. So is that part of the null or alternative hypothesis?
Alternative.
Good. That's part of the alternative. So if that's the alternative, then my null hypothesis has to be this. By the way, don't put p hat here. In your hypothesis, we always test claims about population parameters. P hat would be a sample parameter or a sample statistic. Step 2 is decide what alpha is. Alpha in this case is 0.01. That's our significance level. Great. Nope, down here. Step 3 is to input your data or summary statistics. Well, that's already been done for us because we've actually already got the output from that data. That's up in the problem, up here in this little box. So there's your data. And I'll circle it in purple. Okay, so based on this, we can jump to step 4. Step 4 says to determine our p-value. Okay, what's the p-value here? We got to be careful. I'll give you a hint. It's highlighted. The p-value, good, 0.044, we'll call it. So let's continue marching on with our steps here in terms of the hypothesis test. So step 4, find the p-value, got that. Now we need to compare the p-value to alpha. If the p-value is less than alpha, then we're going to reject H naught. So let's do step 5, our p-value and alpha. Our p-value was 0.044, alpha was 0.01. What symbol goes in here? Less than, greater than, or equal to? 0.044 is greater than 0.01.
And how do you decide if it's greater than?
It's just a bigger number.
Okay.
So 0.044 is bigger than 0.01. I hope I don't seem flippant. I'm not trying to be flippant or anything like that.
Oh, I just meant, how do you know if which way to put the symbol? Like, how do you know if you put it greater than or you put like less than?
Because this is a bigger number, right?
Okay.
Let me put another 0 here. So 0.044 and 0.010. So is that a little bit more clear now that this is a bigger number than this?
Yeah.
1,000 compared to 10 1,000ths. So yeah, that's where it goes. Now,
Could you scroll up just a little bit, please? Oh,
Sure. We've got to decide what that says about our null hypothesis. Do we reject it or do we fail to reject? And let me remind you what we said about this back in section 8.1. If the p-value is low, h naught must go. So in other words, we reject h naught if the p-value is less than alpha. Is that what we got here?
No.
No. The alternative, the other side of this, is if the p-value is high, h naught will fly, meaning you're going to fail to reject if p is greater than alpha. So the decision here that I want to see is fail to reject h naught. And I'd appreciate if you put h naught, even though that's the only thing we typically reject or fail to reject, because sometimes people get confused on that part. So p is greater than alpha, fail to reject. Nice. There's one last step here, but it's an important one. Step 6. Before I get to step 6, let me remind ourselves that I think this was our original claim. All right. Now, why do I need to know that? Because step 6 asks us to word the conclusion. You got to tell this to somebody so that they can understand it. You don't want to give it to them in statistic speak. You want to put it in words that they can understand. That's why this sheet here is going to be your best buddy. That's going to get you through a lot of these problems. So let's start out here. Does the original claim contain the condition of equality? Well, that was back here. Does the original claim contain the condition of equality? Somebody make me look good.
No.
No, thank you. It doesn't. So that brings us down here on the no branch. Then we come to this one down here. Do you reject h naught? Did we reject h naught or do we fail to reject h naught?
Failed to reject.
Fail to reject. So that means we're going to start out the wording of our conclusion this way and just copy it down exactly. There is not sufficient sample evidence to support the claim that, and then we'll state the original claim in words. But let me start by copying this down. There is not sufficient sample evidence to support the claim. And all I'm doing is copying this down. So if you're worried that you're not seeing what I'm writing, it's right there in the bottom of this. There's not sufficient sample evidence to support the claim and I got to catch up with my words here. And now we got to state the alternative hypothesis or the original claim in words. There's not enough sample evidence to support the claim that the percentage of, I got to think back as to what the question was actually asking, because I want to use words relevant to the question. And that'd be back up here. Percentage of subjects treated for asthma experience headaches. Yeah, let's see, you got to figure out a better way to say that. Let's just say the test subjects experience headaches at less than a 9% rate. Yeah, that's a little bit better. Test subjects who've got a headache was less than 9%. So being able to state your conclusion in words is fairly important. Now, we were talking to Mary just a little bit ago. I'm not sure if the next test is going to be through my math lab or not, but either way, I do put a fair amount of importance on this. If this was kind of like a face-to-face test, then these problems are typically worth 12 or 13 points. 4 of them would be for wording the proper conclusion down here. So it's like a third of it. The other things I look for is to see that this agrees with this, that your conclusion and your null hypothesis are stated the correct way, that these match. So there's a lot of little things that I have to look for in grading this kind of assignment. But for our first example, are we okay with our 6 steps here? All right.
Yeah, I just have a question regarding step 3.
Yeah, please.
So is data like that always going to be given to us, or do we have to find it sometimes?
There's 2 possibilities. You know, number 1 is that they could let you do this yourself, in which case they'll just give you some raw numbers and you can do it yourself. Or the other possibility is that they could give you some summary statistics and you can do it that way. So it kind of depends. Now in this one, we actually do have enough information to do it ourselves. So why not let's practice it and see that we get the same output or similar output from Statistic that we got from a graphing calculator over here. So good question. Let's think. So from Statistic, you want to go to analysis. And I realize that I'm not showing what I'm writing here yet. So it's going to be analysis and then hypothesis testing. Hypothesis testing. And from there, you click that, proportion 1 sample. So that's going to take us where we want to go. Let's see. Our level of alpha in this one was 0.01. The claimed proportion. So the claimed proportion comes from your alternative hypothesis. In this case, it's going to be 0.09. I mean, not, I said your alternative hypothesis. It comes from your null hypothesis. That's the claimed proportion. Same thing either way, I suppose. So we'll put that in there. We need the sample size. I think that was 253, but let me just double check that. Yeah, it's 253. And of those, 15 experienced headaches. So that's, perversely, that's the number of successes in this particular problem. So sample size was 253. Number of successes was 15. When you get all that in, click evaluate and let Statistic do its magic. So it's pretty much matching, I hope, all the stuff that we got from, well, we see some of the stuff that it got from. There's one thing that I didn't adjust. Does anyone see it? What I didn't adjust here? Didn't adjust this menu up here. The alternative hypothesis, you have to do that. If you notice, our p-value is about twice what we had when we looked at the calculator data. And that's because I didn't choose the correct p-value. In our case, or excuse me, alternative hypothesis. In our case, the population proportion is less than the claimed proportion. So good thing I made a little mistake here, but we caught it. There we go. So that matches things now. There's your p-value, about 0.044, like we had just a minute ago. And our conclusion would be the same. That is, you fail to reject the null hypothesis. So appreciate the question, Jalal. Really helpful, very helpful. A different way you can do your hypothesis test is to look at the confidence interval. So the confidence interval in this case is from 0.024 to 0.093. Does that confidence interval contain this value? Does it contain 9%? Let's take a look back. Is 0.09 inside the confidence interval?
Yeah.
Yeah. So if it's inside the confidence interval, then you really can't get rid of this, because one of the possibilities, according to your confidence interval, is that P equals 9%. So you can't reject this. So it's good that we're getting the same conclusion in a different way. All right. Yeah, I think we got a lot of good stuff out of that one. Any other wrap up or thoughts on this one? Okay. Let's see. So you asked about doing some with your own data. So here's some of my own data. Yay. And I'm happy that we can finally do this example. My daughter's been killing me. She's like, have you eaten those M&Ms yet? I'm like, no, we haven't got to the right spot in the course. So there's the M&Ms. All of them, I opened them up just this afternoon. And I can only assume that this comes from like the Hackettstown, New Jersey plant. And I looked up online to see if, see what their, where is it? See what the proportion of M&Ms should be by color. So there's two different plants. There's the New Jersey one and the one in Cleveland, Tennessee. And the proportions are different, which I don't know why. I guess part of the country likes a different mixture than another part. Whatever. Let's assume that we got M&Ms from the New Jersey factory. And let's do a hypothesis test to see if our data is consistent with the claimed percentages or proportions. So we can do this for one color. I don't want to do this for all these. So take your pick. What do you got? Which one do you want to do? What color? All right, blue it is. Now here's the actual numbers that we got here. And let me write down a little problem for us. And it would look like this. So we'll call this example B. Test the claim that the percentage of blue M&Ms is, what was it? 25%. And we're going to test that claim at the alpha equals 0.05 level. 0.05 because if we get this wrong, it's not really that critical. So I'm not going to worry about it. But that's the claim that we're going to test. Let's see if we can't set up HO and HA. So the proportion of blue M&Ms that we want, blue M&Ms is 25%. So that's our original claim. P equals 0.25. What's the alternative?
does not equal 0.25.
Perfect. So there's step one. P does not equal 0.25. Step two was decide on alpha. Step three, we're going to have to input some data. And for that, let me look back at my sheet here. We had 20 blue M&Ms, so X would be 20, and then N would be 102. By the way, these bigger bags of M&Ms seem to be pretty consistent, around 99 to 102 M&Ms in those bigger bags, is what I've been getting anyways. We should take a moment and check that this satisfies our hypothesis for our hypothesis test. For that, I can look back at our handout. The observations are from a simple random sample. We're just going to have to assume that. This does satisfy the binomial random variable assumptions. We have a fixed number of trial that was N is 102. They're independent. Yes. Two outcomes, blue or not blue, and same probability of success throughout that. Now you have at least 5 successes and 5 failures. In fact, we got 20 successes and 82 failures. So both of those work. We've got our null hypothesis. We decided on alpha. Let's input our data or summary statistics. So that's going to be in Statistic. All right, so as a reminder, go to analysis, then hypothesis testing, then proportion one sample. And it kind of clears things up a little bit for me. That's okay. Before I forget it, let's put in the form of the alternative hypothesis. So this one is proportion is not equal to the claimed proportion. This one's greater than, this one's less than. Which of these three match what I have here? First one, second one, or third one?
Third one. Or first one, first one.
First one? Okay, I agree there. So it's the first one, so leave that there. Significance level, 0.05, we're good there. The claimed proportion, you remember where that comes from? Right here, that's your claimed proportion. 25%, so 0.25. Sample size was 102, and the number of successes was 20. So it's kind of falling short of what you might have expected. Maybe you expected like 25, but is it short enough that we're going to say, you know what, we're going to throw out the null hypothesis? Let's find out. So step 4, what do I need from step 4 here?
P-value.
The p-value. So the p-value is 0.2085. Nice. Step 5 is where you decide if you're going to accept, excuse me, not accept, but reject or fail to reject. So let's take a look at our p-value and alpha. Our p-value was 0.2085, alpha was 0.05. If it helps, you can put 0.0500, Maybe that'll help you with the comparison. Which one's bigger? Should I put a greater than or a less than sign here?
Greater than.
Greater than. This is bigger than this. Yeah. So what's that say about our null hypothesis? Do we reject or fail to reject? If the p-value is low, H naught must go. If the p-value is high, H naught will fly. Which one of these am I going to use? Top one or the bottom one?
Bottom.
Yeah. P is greater than alpha, so you fail to reject. So fail to reject. This was our original claim, and we need that for our work in step 6. Step 6 says state your conclusion in words. Let's go back to that handout. Wording the conclusion. And can I zoom up a little bit? Not all the way up. Starting over at the left, does the original claim contain the condition of equality? Yes or no?
No.
Yes.
Oh, no, it did. It did, yes.
It does. Okay, so that's a yes there. So that brings us over to here. Do we reject H naught?
No.
No. So our conclusion is this. There's not sufficient evidence to warrant rejection of the claim that 25% of M&Ms are blue. So you always start out, you write exactly this, and then you have to write your original claim in words. So there is not sufficient evidence to warrant rejection of the claim Now we got to state our original claim in words, and that's going to be that 25% of M&Ms are blue. Whew. There you go. Well done. Well done. Now, we did get less than we might have expected. I mean, we would have expected around, 25 or so if we got exactly as many as what the website suggested, but, we didn't get so few that we could reject that claim, or we didn't get too many so that we could reject that claim. We got, we're somewhere in no man's land. Our p-value was almost 21%. So it wasn't conclusive in any direction. So you failed to reject. Nice. In all the years I've been doing this, I've never found a bag that rejected H naught. Keep on hoping, but didn't happen this year. All right. How are we looking on this one? Should we do one more to finish off this section? Hopefully make you feel pretty comfortable with these things.
Yes.
Yes, please.
Okay. All right. Appreciate that. Let's go down to example C here. And, when you do these on my math lab, it's going to look a little different, but you should still be able to come up with the same Same numbers. We're going to run through the same procedures. It's just that they have to ask questions kind of in a bit by bit approach. So example C talks about a study of 806 randomly selected medical malpractice lawsuits. It was found that 492 of them were dropped or dismissed. Use a 5% significance level to test the claim that most medical malpractice lawsuits are dropped or dismissed. So our original claim, most lawsuits are dropped or dismissed. Now, when you're talking about most, you're talking about a percentage. So you have to be talking about P. And the percentage that means most is when you're greater than 50%. So that's our original claim. Now I'm thinking and hoping that along the way, we'll get all the things we need to fill in things for example C. But here's step one, our null and alternative hypothesis. What's HO? What's HA? Someone now to get a chance to speak tonight. Joshing, who would HO, or where would this one go? Is that part of HO or part of HA?
Would it be part of HA?
Good, it's part of HA because it doesn't include the possibility of equality. Thank you. How about here? HO, what's this one gonna look like?
P is less than or equal to 0.50.
P is less than or equal to 0.50. Now, just as a reminder, in my math lab is probably gonna be just this. All right, but in any case, this has to have the possibility of equality. So you probably, I'm not even sure that they would show that symbol as part of your choices when you input things. Yeah, all right, they give you a bunch of different choices here, but they don't put a less than or equal to. So let's see, we want to test this. Step two, we want to make this test at the 5% significance level. So, okay, step two. 2 alpha equals 0.05. That's a standard level. That's very, very common. Step three, we're going to need to gather some data. We're going to need to input some data. So the relevant things we need to find here are X and N, the number of successes and the number of total possible cases. So those numbers are 492 and 806. Let's put those into Statistic. And as one last reminder, go to Analysis, then click Hypothesis Testing, Proportion 1 Sample. Let's adjust our alternative hypothesis first if we need to. Which of these three matches this alternative hypothesis? So let me open that up again. Do I want 1, 2, or 3? The population proportion, so that's your parameter. Is it not equal to the claim proportion? Is it greater than the claim proportion, or is it less than the claim proportion?
Would it be 2?
It's going to be greater than. So it's going to be 2. All right. 5% significance level. What's the claimed proportion for us in this particular problem? Does anyone know?
0.5.
0.5. Excellent. So let's type in a 0.5 there. Might help if I had a cursor on this. 0.5. Sample size was 806. And the number of successes was 492. Sometimes it's kind of funny. The number of successes does take on a perverse kind of meaning or feeling sometimes. But there we go. All right, so step 2, or excuse me, step 4. What do I need here for step 4? What information should I copy down?
The p-value?
The p-value. Nice. And what's our p-value here?
0?
Yeah, 0. And I'm also going to write down the z statistic, or our test statistic. Z is 6.269. So maybe we can take a look at this in a different way. But yeah, those are the numbers that we need. Let's go back here to step 5. Step 5 is where you make your decision. This is another step in which I give a fair amount of points, because you could do a lot of the right work to get here, but if you make the wrong decision, then everything's a waste. So you got to get this part right. Now let's compare our p-value to alpha. Now our p-value was 0. It was a flat line 0. Meanwhile, alpha was 0.05. What symbol is going to go in here? Less than or greater than?
Less than?
Less than. What's that say our decision is? What are we going to do with our null hypothesis? Ah, got to look back. That's okay. I'm glad you're looking back. If the p-value is low, finish my sentence.
Reject it?
Yeah, H naught must go. So we're rejecting it. Reject H naught. The p-value is less than alpha, reject it. So that puts us in step 6. Before I move on, are we okay with this one, that we're rejecting H naught?
Yes.
All right. So let's look up here. Let's see, not here. How about there? There we go. Oh, I had it right. Ooh, I forgot the original claim. What was the original claim here in this one? Let me look back here at the problem. Most medical malpractice lawsuits are dropped. So is that original claim? Oh, yeah, actually I did write it down. That original claim is part of which hypothesis?
HA.
HA, that's where your original claim is. So, okay. We need that to help make our decision here. Does your original claim contain the condition of equality? Which branch should I follow, the yes or the no branch?
No.
No branch, yeah, because it doesn't contain the condition of equality. Do we reject H naught?
Yes.
Yes. So the sample data support the claim that, and then we got to state the original claim in words. So let me write that down first. Sample data support the claim. Now this whole thing really needs to be done in words, so that way somebody could read it and understand it. I want simple words. That the majority of malpractice cases are dropped. Or dismissed. All right, but that's the important part here. Nice. Are these starting to become a little bit routine? You know how to work your way through these things?
So for 6, how do you decide at the beginning of the flowchart if it's yes or no?
Oh, that goes back to the original claim. The original claim in this one said test a claim that more than the majority of these cases are dismissed or dropped. So that was this claim right here, and that became part of the alternative hypothesis. So when you look at your flow chart, does the original claim contain the condition of equality? Well, no, because it was just a greater than. It wasn't a greater than or equal to, wasn't a less than or equal to, wasn't an equal to, it was just a greater than. So that's why we chose to go down on that first chart or first decision box as opposed to the right.
All right, thank you.
Thank you, Sarah. Anything else? You guys ready to do these? Let's take a quick look at what the rest of C was. I think we've got all the things we would need for C. So the correct answer here would be F, because they're going to put equals as opposed to less than or equal to, but the alternative hypothesis is correct. We've got the correct Z value here. The P value would be just a flat 0. And then the conclusion is that we would reject the null hypothesis because the P value is less than or equal to the significance level. So that'd be D here. And then you can state your conclusion in words. All right, and we did that. So are we looking okay on these? All right. All right. Well, let's call it a day in this section, and we'll take a break here. Let me just stop the recording here real quick.